Rochester has to beat us twice to make it to the playoffs, make it have the tiebreaker come back.
Oh, yeah.
So,
Okay, so I don't think I want to try and draw this sphere,
I don't know.
but they give us a formula. It says a sphere of radius 3 inches is sliced with two parallel planes. One passes through the equator, and the other is 8 inches above the first plane. The resulting portion of the sphere between the two planes is called a spherical segment. So can you kind of picture that?
Do you want a situation?
What?
Yeah.
What do you say?
You want a situation?
Yeah, I would love a situation.
Let
Okay, get back to it. All right, and then this is, someone figured out the volume formula for this funny shape. So it's pi over 3 times h times 27 minus 8 squared.
Wait, the first one's so easy.
Well, that's good.
Did you
A,
just look
find
at
the
the
volume of the spherical segment if h equals
Oh,
1.
that makes me happy.
Yeah, that is good. So you plug in 1, and you get,
Is that secretly comprehensive?
nope, I don't think so, pi over 3 times 26, right? So the volume would be 26 pi over 3. Yeah. Okay, any questions? Kyle, you awake?
Yeah.
Okay, good. B, find the rate of change of the volume with respect to h of the spherical segment at h equals 1. So that's not bad either. Take the derivative. So we're going to go product rule here, right?
Yeah.
So first one, times the derivative of the second one. What's the derivative of the second one?
Negative 2h.
Negative 2h. Plus the second one, times the derivative of the first.
I think we're very close to it.
Got it.
Right.
You got it? Okay, and then it says find the rate of change of the volume with respect to h at h equals 1. So plug in 1. And that is a little bit gross. It is going to be negative 2 pi over 3 for this stuff. Goosh. What is it? Okay, plus another 26 pi over 3 for this stuff. Kyle is not only awake, but he's participating. So if I add those together, I get 24 pi over 3, which reduces to 8 pi. Okay. All right, use the tangent line approximation that h equals 1 to estimate the value of h that will yield a, what did I win? Oh,
It's here already?
so now we have to use this tangent line approximation thingy, which is not a big deal. I'm pretty sure that we didn't do it correctly yesterday, but we can do it correctly today. So when it says use the tangent line approximation at h equals 1, that means come up with the equation for the tangent line when h equals 1.
Oh.
Okay? And then we're going to use that to approximate the answer for somebody having a volume of 25 cubic inches. Hello, I need an eraser. So I'm going to erase, because we're all floating around in outer space now. So I'm erasing that section of the planet, and Sophie's at home going, what? Why are we in outer space? It's a long story. So now we need to come up with a tangent line for where h equals 1 and v equals 26 pi over 3.
Wait, why does it equal 26 pi over 3?
Because that's what we got when h equals 1, and that's why they wanted us to figure that out, because we need to know that point in order to come up with the tangent. Okay? So volume minus 26 pi over 3, because those are essentially our y values, right? Equals the slope, which is 8 pi. Figured that out when we plugged in 1 times the height minus 1. Okay? What is this as a decimal? 26 pi over 3. Sweet. 27.23? Okay, so with the tangent line approximation, you can only do it with values that are close to the ones where you have the tangent line for it in the first place. And so this will work because this is 27.23. They want us to do it for a volume of 25 cubic inches. Those are close enough, so this will be an approximation. So I'm going to plug in to this equation of the tangent line, I'm going to plug in 25, the volume that we want, and then I'm going to solve this for H. Does that make sense? Okay. Should we just go to decimals here, make our life easier? Or should I distribute an 8 pi and then keep pi's in there? What do you want to do? Distribute an 8 pi. Okay. So 8 pi h minus 8 pi. So I'm going to solve that for h. So I have to add 8 pi to both sides, and we figured out that 8 pi is really 24 pi over 3, right?
Yeah.
So negative 26 pi over 3 plus 24 pi over 3 is going to be 25 minus 2 pi over 3 equals 8 pi h. Right?
All right.
Does that work? Okay. How do I get rid of the 8 pi? Divide by 8 pi, or
Inverse.
multiply by the inverse, because I want some pi to cancel, so I'm going to multiply both sides by 1 over 8 pi. So those are gone. So h equals 25 over 8 pi minus, if I distribute this 8 pi through here, the 2 pi's cancel. 1 times 2 is 2, 8 times 3 is 24, which reduces to 1/12. So if you want to be cool, that's your exact answer for the height. So let's figure it out as a decimal. I hope it's kind of close to 1. What is it? What's 25 divided by 8 pi minus 1/12? Well, this is pretty close to 25, right? Because 8 times 3 is 24. So, I mean, it's close to 1. Yeah. You got what? 0.818.
What did you get? Discrepancy.
To the Bat Cave.
I think it was like.
Right, and the reason that is because when you go 25 divided by 8 pi, the 8 and the pi have to be in parentheses. Because you want to divide by both the 8 and the pi. If you go 25 divided by 8 pi, then it goes 25 divided by 8 times pi.
I don't know what's going on.
It's a world gone crazy.
I got point there.
Oh, you see matches with Kayla, so you're in trouble. So it's 25 divided by 8
Oh, I
pi.
divided by.
Whoops.
You found it all.
Minus 1/12.
Equals.
0.911.
Yeah. 911.
0.911.
Oh, yeah.
But if you take out the decimal,
Yeah, but then it doesn't make sense anymore, so.
but then it's just 911.
So I'm going to just give a little brief chat about what we're doing here with this tangent line approximation, because I don't know that we've talked about this before. So what's happening is you had a graph of the volume of the thing. I don't know what that graph looks like, okay? And we took the value h equals 1 and found a tangent line to that, right?
Yeah.
And so what the tangent line approximation is, it's saying if I want to know what the value of this is at this point right here, instead of plugging that into this crazy weird function, as long as I'm close to that point, if I plug it into the equation for the tangent line, then I'm pretty close to the real answer also, right? Because the tangent line is very close to the graph near the point of tangency, okay? So all it is it's using the equation for the tangent line to find the value of the function instead of using the function itself. Okay? Do we have the technology to plug in 25 right here for the volume and figure out the exact answer for h? Yes. So why do we do this? I don't know. So it's kind of like the linear approximation thing, where you have to do more work to get a bad answer than doing less work to get the exact. Which is maybe why my son doesn't want to major in math.
That could be.
It doesn't make much
I
sense.
think that's a good reason.
It's not his reason.
You might
What's
be,
his
well,
What's your major?
you do major in art?
You know, the thing is, yesterday after we had our baseball game, we all met in the center, kind of, I don't know, late, we were talking and trying to figure out how we were gonna settle this league battle deal. So, the smartest kid, that was me, and
Uh-oh.
the
Now you're gonna
youngest
call
kid
it. You're the
from our
smartest
team,
kid.
which was Richard, and then the smartest and dumbest kid from their team, and we did trivia questions, and it was supposed to be sports trivia. So I asked him a question, and he didn't get it right. Yeah!
All right, so we got this triangle here, right? And then everybody knows the law of sines. That's not usually how we do the law of sines in high school. Usually we do sine of A over A equals sine of B over B, because they have a different way. Okay, then this says, suppose that A and B are pieces of metal which are hinged at C. At first, the angle A is 45
All of the
degrees,
above.
and the angle B is 60 degrees.
Oh, fine.
You then widen A to be 46, so we want to make this be a little bit bigger, without changing the sides A or B. So we want to make this angle bigger, but we want to keep a triangle, right? And so if I'm going to do that, then this is going to go up, and then that's going to change that angle right there, okay? So our goal in this problem is to use tangent line approximation to estimate the angle B when this is 46, okay?
So what happened, it's just staying the same, angle C is staying the same.
Angle C is staying the
And
same.
then it's just moving a little bit.
Yeah. Oh no, it says they're hinged at C.
Well, I know, but there.
That's going to have to change. I don't know. Notice that the angle B is a function of angle A, i.e. B equals f of A. Consequently, it makes sense to calculate the implicit derivative dB dA equals root 3 over 2 root 2, and then we're supposed to fill in the blank. Anybody got anything there? Well, I'm assuming we're going to use the law of sines here somehow. It says, notice that angle B is a function of angle A. Anybody got anything for us? Oh, that's some good news. Okay. Hi, Sophie. So we divided this into, for those of you that are chatting or thinking of a story on your own or sleeping in the back, we're going to take and divide this into two triangles. So this is 45, 45, 90. So that means that this side is B, then this is B over root 2, and this is B over root 2. There's your root 2, buddy. And that means that this is a 30, 60, 90 triangle. And so since this is a 30-degree angle, this is half the hypotenuse, or 1/2 A. And this is going to be the short leg times the square root of 3. And then since these two things are the same line, that means that B over root 2 has to equal root 3 over 2 times A. Okay? So what I'm going to do is I'm going to try and solve this for B over A so I can substitute that in there. And then I have a function of A and B, and then I can take the derivative. Okay? So Cody said multiply both sides by root 2, so I did. So B equals root 3, I lost my root 2, times root 2 over 2 times A. And then all I have to do is divide both sides by A, right? And B equals, B over A equals root 3 times root 2, which is root 6 over 2. Okay, I'm just going to still go with it even though we lost the root 3 and the root 2 in there. So root 6 over 2 equals sine of B divided by sine of A. So B equals a function of A, so I'm going to solve this for B by multiplying both sides by sine of A. So root 6 over 2 sine of A. What? Yeah, I know. We got fully hosed here. That last one was so easy. And then if I do the inverse sine thing, then B equals the arc sine of root 6 over 2 sine of A. Okay? So there, that's what we got going on when it says, notice that the angle B is a function of angle A. So B equals a function of A. So here is our function of A. How much fun does that look like? Okay, let me recopy that over on another page because we have to take the derivative of it. And then Austin can tell us the story.
Yep. Got it.
So B is equal to the inverse sine of root 6 over 2 sine of A. Is that right? Okay, now did I screw something up there when we were solving for B over A? You don't know? I mean, this is right, isn't it? That if this is B, then that's because that'll be B. Yeah, and that'll add up to B over. Yeah, I just want to make sure we didn't make a silly math mistake here. So that's half of A. That's root 3 over 2 times A. Okay, I think we're all right. So hopefully things will come back together for us. Okay, so now let's figure out for A what dB/dA is. So what is the formula for the derivative of the inverse sine function?
I got this one.
Ruthie's got this one.
I got this one. 1 over square root of 1 minus x squared.
1 over square root of 1 minus x squared. So my x is this thing right here. So that squared is going to be 6 over 4 sine squared of A, right?
Yes.
And I have to multiply that by the
Which is
derivative.
root 3 of.
It might come back to us.
Let's try to
though.
make it work in my head.
It might come back to us somehow. Anyway, times the derivative of this thing right here. What's the derivative of sine? Just cosine. So that's going to be times root 6 over 2 cosine of A. Okay? All right, so let's get our root 3 over root 2 back. So I'm going to get a common denominator here. So I'm going to make this 1 over the square root of 4 over 4 minus 6 sine squared A over 4, right? I can do that? Okay. You okay with that, Austin? All right. So then if I factor, I'm just going to do the square root part for right now. So if I factor out a 1/4 from that, then that leaves me with 4 minus 6 sine squared of A underneath the square roots. And the square root of 1/4 is, oh dang it, I almost had it. The square root of 1/4 is 1/2. So that means I can take this and put it out there. And then I flip it over and multiply, so the 1/2 actually becomes a 2 up here, which I'm multiplying by the root 6 cosine of A over 2, so those 2's cancel, and I still just have a root 6. Oh well. So we did something wrong in there somewhere, but we were close, right? Okay, so for for B, then we have to plug in pi over 4 and pi over 3.
Ew.
Oh, and that's when we know we're in trouble because they want us to plug it in for A and for B, and we don't even have a B anymore. Yeah, we get too creative. Okay.
Teachers are always
So I screwed up because it said to calculate the implicit derivative, which means you don't have to solve for one of the variables. And so we didn't have to do this step here where we solve for B. So what I did is if you take sine of B equals the square root of 6 over 2 sine of A and multiply both sides by 2, then you get 2 sine of B equals the square root of 6 sine of A, right? And then you can take the derivative of that using implicit differentiation. The derivative of 2 sine of B is going to be 2 cosine B times the derivative of B, which is dB dA. And then the derivative of this is going to be the square root of 6 cosine of A. And then this would be the ADA, which nobody cares about, right? Because ADA is just 1. So then you divide both sides by 2 cosine of B. And I'm so close to having the right answer that they want on the thing. I just need that to somehow be root 3 over root 2 and we're good. So I feel like I did something wrong with this triangle over here. But then that gives us as our final derivative, so the answer for A is the BDA is, it's supposed to be root 3 over root 2 cosine A over cosine B, but somehow we got root 6 over. Sorry.
No, I think I want to return just mine and get this one off myself.
Anyway, so do we have any time left? No. So you guys could, well, I guess we'll do this tomorrow. I'll save this and then finish it tomorrow. So then when it says plug in the angle for A and B, now it makes sense because now our derivative has both an A angle and a B angle in it. You know what I'm saying?
Just
We're
so
right
right
where whole slide idea then though, like.
Yeah, definitely. But I'm gonna maybe if I have time go back and recheck that and see how come I have root 6 over 2 instead of root 3 over root 2. Oh no. Oh no, we're fine. Because guess what? If I take root 3 divided by root 2 and I rationalize the denominator, what do we get? Root 6 over 2. So this is the same thing as root 3 over root 2. Okay, so yay, did it right. So that's the derivative that we're looking for there. Okay, so we'll do parts B and C and D tomorrow, and then numbers 17, and we'll be good to go.